Alright, so the purpose of this video is just to try to help you make connections between what we've learned in earlier parts of the course and connect those into some of the newer stuff we learned about carbonyl chemistry. So let's say we want to make this compound. Now we could look at this and say, oh, this is a beta hydroxyketone. And where do we get beta hydroxyketones? Well, this is going to come from an aldol reaction. And that would be the alpha position, that's the beta position. And so if we work through this going backwards, we're going to ultimately need, and I'm going multiple steps backwards, not just simply one at a time. We're going to need these two carbonyl compounds. Since it's an aldol reaction, we're going to have to use LDA, and we're going to have to mix all our reagents in a specific sequential order so that we get just the beta hydroxyketone. But you might be able to see this in different ways. If you were required to make this molecule, this beta hydroxyketone, you may be easily go back to these carbonyl compounds. But what if I said you have to start with these alcohols to get to this compound? You might say, wow, that's kind of weird because I don't see any carbonyl compounds, but clearly I need to do an aldol reaction. So it's important to recognize when you're given alcohols, you can always think of an alcohol as a hidden ketone, either by a Swern oxidation or a PCC oxidation. Furthermore, what if I said, okay, I want you to make this final product, but your starting material, one of your starting materials must be cyclohexene. You might say, holy smokes, where's the oxygen? Well, we can put in the oxygen. We can think of this alcohol as having come from an alkene simply through a hydration, which could be water and sulfuric acid. So all these other reactions, so this goes back to our addition chapter, and of course we've seen carbonyl alcohol oxidation reagents, the PCC and Swern. So we need to be able to think of this more just, oh, I need these carbonyls to make this carbonyl-based product. We can get our carbonyls from other reagents, from alcohols, we can get them from alkenes, and so all these reactions stitched together. This is really challenging to do, to think backwards, but it's part of the organized planning that you need to put into practice in order to do a retrosynthetic analysis.